we talk about impedance matching, right? So now we will start designing an low noise amplifier. This is a little bit complicated. We spend many classes on this. So the first thing is low noise amplifier usually is single stage. Turn out to be very easy. That is because we want to have a very low noise factor. If you have many transistors, then you are going to add a lot of noise, right? That's why usually it's only single stage. As simple as a common source amplifier and common gate amplifier. Okay? So this is already a low noise amplifier. So simple. Now, we need to do impedance matching because we are talking about RF. How are you going to able to deliver a signal from one place to another place? It's just this is high frequency signal. So it's like a transmission line, like the water wave. You need to be able, it's just like your ocean has a very big water wave coming to the shore, but why it get attenuated? Because there's no impedance matching, right? You have this, what do you call, barrier, damper or something to damp the water wave. That is the opposite idea. You try to reduce the impedance matching so a water wave cannot propagate the energy to the shore. On the other hand, our goal is that whatever wave you have here, I want you to be able to propagate the energy to here, right? So that's why we need impedance matching. If you just want to get the resistance correctly, you just want to get the voltage, then yes, you just have an infinite input impedance. That would be the best. But that is usually not the case in our circuit because between the antenna, first you might have a long trace of metal wire like this. Then you are going through a transmission line. You really need to match the impedance. Otherwise, all the signal will get reflected. Okay. So anyway, just take it for granted. Now the point is, if I have a RS which is 50 ohm, how should I design my circuit so that I can match it? And to match it, as we remember earlier, the maximum power you can deliver is what? When the source and the destination has the same impedance, or conjugately match for the if it's a complex number, but we don't discuss now. We just assume it's real. So they need to have the same value. Okay. So what can we do? How can I match this one? Because for a common source amplifier, your input impedance, you can treat as infinity, right? Or very large. It definitely is not 50 ohm. Okay, one possibility. Let me just add a resistor here, Rp. I make Rp equal to Rs. Then they will be matched. And then I can get the maximum power delivery, right? But the problem is this, is going to generate noise. Okay, but we will look into it. So this is the most straightforward, but it's not a good idea. Of course, we also have other parasitic because we want to match to 50 ohm. Earlier, we said that actually you might have some parasitic capacitance, right? Because you are a transistor, you also have wire, and we usually will also add an inductor to cancel it. So here we assume we cancel it successfully. So we don't have the imaginary part. We only have the real part. So it's the 50 ohm and 50 ohm. Okay, so this is one way to match it. Any questions? Now, if no, then let's look at it. If we try to match in this way, what do we get? In this slide, we already showed that when we try to find out the noise of this circuit, we will just assume no signal, right? Because due to superposition, we assume there's no signal because we're just studying the noise. These two are going to get parallel, so it's Rs parallel Rp. So the noise is 4 kT Rs parallel Rp. At the very beginning, we have done an exercise, right? You do it either through parallel or you try to decompose into 2U superposition. You both get the same amount of noise, the PSD, right? Okay. So let's look at it, and that's why we have this drawing. Are you okay with this figure now? So I want to look at the noise figure when I do impedance matching by adding a RP using resistive matching. Okay, so what is the output here? What is the output noise overall? So how many noise do we have here based on these figures? How many noise source do we have? Very good. You saw 3. Which 3? S parallel RP, drain to source, and RD. Well, good. Actually, I thought it's 2, but we did not draw RD. We also have RD, right? So I can write down the V out right away. Again, I ignore the figure noise. V out square. First of all, I claim that it is RD for KTRD. Is this okay? Because I have a voltage, I did not draw it, but if I draw it, here I have the 4K. Remember, I need to ground this one because it's small signal, and this is 4KTRD. This appears directly in the output, right? If you try to draw the small signal. So this is the contribution. What else? I have 4KT gamma GM, but this is a current. How will it become a voltage? It's going to flow through RD, right? So times RD squared. Because when you try to do superposition, this is grounded, so you don't have the GM. So this one, everything will flow through RD. Do you see this? Assume you don't see this. Then what will you do? Draw the small signal model. GM, VGS, plus minus VGS, grounded here, RS parallel RP. Then you have this source, right? And then this is RD. Again, it's grounded. And then I should push this to the right. I add the source first. This is 4KT gamma GM. And then RD. And this is V out. Very ugly drawing, but do you see this? Do you agree with what I'm drawing? This is important. Yeah. Can you speak louder? Alpha. R out. Very good. I did not. Here I assume no channel length modulation. Yeah. I should, but assume no channel length modulation. So no R out. So now here, what is VGS where I do superposition? Of course, then I assume there's no noise from here, right? I do it step by step, right? We do treat it individually. So there's no noise. So VGS is 0. GM, VGS is 0. All this current will flow through RD and give me V out, right? Current times resistance is the voltage. And that's why I have 4KT gamma GM RD squared. Why RD squared, not RD? Because what? I'll get the unit right. But getting a unit right is the aftermath. I mean, but not because we want. Of course, we need to get the unit right. But what is the physics behind this? What is 4 kT gamma GM? Is it the current or what? Yeah, it's the square, right? Current is the noise spectral density, right? So of course you need to multiply RD square. The current multiplied by RD, then is square multiplied by RD square. Give you voltage square. So I already drawn this circuit. Similarly, when I want to consider the noise due to the input, then I don't have the noise here. What is the Vout due to this input voltage? Input due to this input noise, the source noise. It must be, what's the noise itself first? 4 kT Rs parallel Rp. This is voltage square. But it is just like the gain. What is the gain of the circuit? GMRD. Then you give you the output. So square give you the output power, noise power. So that is the output noise power. Right, so now you need to develop this skill. Hopefully you don't need to always draw the small signal model, but just looking at this, right, after you keep practicing, go to the textbook. Actually, this comes from the textbook. Look at the example. The author has a very detailed description to understand how they do this. Right, so now I lump the free noise source into one single voltage noise at the output. The reason I do that is because then I know the noise figure equals to 1 plus, or not 1 plus, it's the whole thing, right? It's equals to Vn out squared divided by alpha square A square divided by 4 kTRS. Again, alpha equal to 1 in this case, right? Alpha, because there's no potential dividing effect, I have infinite input impedance. And A, I know what it is, right? What is A? Say again? GMRD, right? So GMRD squared. So this is just equal to Vn out squared divided by Gm square Rd square 4 kTRS. Am I right? I'm wrong. What did I do wrong? Very wrong. It's about the alpha. So I'm sorry. This circuit looks like the case, but this is the simplified case that we use for the noise calculation. Isn't that we're talking about impedance matching? We actually add Rp so that you match the impedance. So the voltage sensed by the here, what is this voltage here? Vx equals to V in times what? Huh? 1/2, very good. But let me don't call it 1/2 yet. You are right. This potential divider, right? Which is equal to 1/2 if it's matching Rs equal to Rp. Okay? So I'm wrong, right? Here alpha. Alpha is not equals to 1. It is equal to what? Rp divided by Rs plus Rp square. Alpha square. Okay, I make this mistake, but do you understand why I make this mistake and why it is corrected in this way? Please ask, right? Don't waste time to study. Just ask now. Any questions? Yeah.
How do you determine what noise at KTRD? How do you know which one?
Yeah. He's asking how do I put positive or negative? Turn out it doesn't matter because what we care is the square. Because we do not manipulate voltage individually in the equation, right? So it doesn't matter how we put it. For example, now it's pointing down, since it's noise actually going up and down, right? But you may get negative RD times the current, but their square is the same. So we don't care. Any questions? Let me double check I'm doing the right thing. So because of this, I need to multiply this by Rp divided by Rs plus Rp squared. Okay, so it is pretty long. I'm not going to derive it, but I want to just work with you for a few terms, right? For example, the third term, and you do it yourself for the rest. The third term is this, 4kt Rs parallel Rp GMRD square. I'm talking about this term. I'm doing V out divided by this guy, right? So this is the third term. Is it okay? I'm trying to do this one divided by this one. The whole thing divided by GM square RD square 4KTRS. I will do this. This is just equal to R. Do I want to do parallel? Maybe no. I keep it. Rs plus Rp squared. Right. So actually, I want to change this one. Rs parallel Rp to Rs Rp divided by Rs plus Rp. Okay? Yeah. Then let's start doing the cancellation, right? 4kt gone. GMRD square, GMRD square gone. Is that okay? And then I only have this left. Then I have Rs Rp on the top. But because at the bottom I have square, right? So Rp squared, but Rs plus Rp, I got cancelled. I have one Rs Rp, here Rs Rp squared, so they got cancelled, then I have this, right? And then you further do that, you say Rp can get cancelled. So you get Rs divided Rp times Rs plus Rp. I think I'm doing something wrong again. Oh, I still have RS here. Thank you. Here I missed the RS here, right? Thank you. So I have RS here. So this RS is gone. Right? So I get R, it becomes 1 plus RS divided by Rp. So the third term gives me this, 1 plus Rs divided by Rp. Okay? Any question about what I'm doing, how I do it? Say again. The third term, this term. Okay? So I'm trying to divide this thing by this whole thing. It's just math, but I just want to go through with you. And you always see 4kt can get cancelled. So with this, then finally you try to do other things. Then you get NF equals to 1 plus Rs divided by Rt. That is what we got from the last slide. And then you have more if you play with other terms. Gamma Rs divided by Gm Rs parallel Rp square Rs divided by Gm square Rs parallel Rp square Rd, right? It's meaningless to remember this. But one important thing is this. When you match, right, impedance matching, you have Rs equal to Rp. then it means NF is equal to 1 plus 1 plus something, right? So it's larger than 2, which is larger than 2 dB, 3 dB, right? Because, which is 10 log 2. When you take 10 log 2, you get 3 dB already. So the noise figure is already as large as 3 dB, which is not good. That is which is not a good low noise amplifier because of RP. Is that okay? Now, at this stage, you are not going to design this circuit in your project, right? There is a very good step you can follow. But now we have tried this, we see that, well, in order to do the impedance matching, I try to add a resistor in parallel, which tricked me also. I forgot I need to do the potential divider effect. And the main point is that because of RP, I have a large noise figure. Think about this, if RP is very large, this will become 0. You are not matching well, but you have better noise figure. It will be dominated by other terms, but this term will be gone, right? Because it becomes 0. So actually, I'm slow. Maybe I will just stop here because we will need to start a new topic, right? It's almost time. Any questions?